Welcome back to Sunrise Ground Video Lab. I'm Sheersh, researcher in the Department of Climate and Space Sciences at University of Michigan and your mentor for this self-training module. Our Sunrise GRL program is in collaboration with Sunrise Space Mission and Radio Joe project. Here, I highly acknowledge my team and NASA funding grants to turn this project possible. In this section, Training Module 3.3, we are going to discuss about future directions and collaborative efforts. As I mentioned earlier, here I am again reminding you some prerequisites understanding which will help you to grab the scientific notation and terminology which have used in these training modules. So these includes basic high school science, high school reading comprehension, electromagnetic wave spectrum, graphical interpretation of data, Training Module 01 and 2. In this section, I am going to talk about advanced research methods and data analysis techniques, future and existing missions and instruments for comprehensive space weather monitoring. I will discuss about encouraging data sharing and collaborative analysis, and I'll wrap up this lecture with the challenges and open questions. Observational data plays a crucial role in investigating the emission mechanism of solar radio burst. To obtain a comprehensive view of an emission process and their connection with other solar phenomena, we need to analyze some properties or characteristics of solar radio burst. Here I am mentioning few of the major characteristics that we need to observe or analyze of the solar radio burst. These includes frequency, polarization, temporal evolution, spatial distribution of solar radio burst, signal intensity calibration, radio wave propagation through ionosphere, and combining observations from multiple instruments and wavelengths. Comparing the data observed properties with the theoretical models and simulation allows researchers to constrain and refine their understanding of the emission mechanism involved. As I mentioned in my previous slide, that if you want to understand overall picture of solar terrestrial physics, then you need to observe solar radio burst along with other solar activities in different wavelengths. Here I am pulling up few of the space-based mission such as SOHO, WIND, STEREO, Solar Dynamic Observatory, Solar Orbiter, Parker Solar Probe, and some future missions like Aditya L1. These missions can provide high resolution and multi-wavelength observations, allowing for detailed studies of initiation, evolution, and properties of solar eruptions. Advanced instruments such as radio spectrometer, imager, and high energy particle detector and magnetometer enhance our capabilities of detecting and characterizing radio burst associated with other solar events. Additionally, dedicated space-based missions and observatories focused on solar physics and space weather provide opportunity for long-term monitoring and continuous data acquisition. Here I am pulling up this website where you can get all the data observed from different spacecrafts and ground-based missions. Here in this slide, I am going to discuss about how this data sharing and collaborative analysis improve your research ability. By sharing observational data, models, and analysis techniques, researchers can validate and compare their findings, fostering more robust and comprehensive understanding of phenomena. International collaborations, data repositories, and open access initiatives contribute to accessibility and availability of data, facilitating collaborative efforts and accelerating scientific advancement in the field. Encouraging data sharing and collaborative analysis also enables the development of consistent and standardized methodologies, ensuring the reliability and the reproducibility of research outcomes. Here, I am wrapping this solar radio analysis section by giving you some challenges and open science question in this field in which you can think and work on later. These include understanding the detailed physical processes responsible for the generation of radio burst, understanding the mechanism behind the timing and spatial relationship between the radio burst and other solar events, unveiling the complex interplay between magnetic field, plasma dynamics, and particle acceleration in solar eruptions, understanding the radio wave propagation impact on ionosphere and Earth atmosphere. Future research should address these challenges through advanced observations, data analysis techniques, and theoretical modeling, which can improve our space weather forecasting. That's all for this session. If you want to understand more about radio physics, space science, solar physics, their observations and analysis techniques, then you can join us in our monthly webinars where you can interact with the space science and radio physics expert and ask your doubt directly to them. Still, if you have any question regarding these training modules, please feel free to drop your question to our website. We will reach back to you with the answers. For more information and being updated, please follow us in our social media platforms. Thanks for your attention. See you in the next module. Bye-bye.